Scientist Mondays with Miss Sherlyn. And if you want to raise your hands, I'm going to do this because I always do it. Or this. Okay, ready? We're going to make our cookie crazy laugh for Mad Scientist Monday. We're going to go, are you ready? One, two, three. For Mad Scientist Monday. So today we're going to do the milk rainbow. I have Dawn dishwashing liquid, simple stuff you can find at home. So I have a glass platter. I have Dawn dishwashing liquid. I have a little container. I have Q-tips. I have Fun-Dip, or not Fun-Dip. I thought it was Fun-Dip. Food coloring. I have food coloring. I have measuring cup, because I need that. And I have milk. So first I'm going to explain what we're going to do and the science behind all of it, just so we know before I do the experiment. I'll probably do it twice, maybe, if it works right the first time. So matter exists primarily as a solid, liquid, or gas on the earth. Solids have a definite volume and a definite shape, such as liquid. It moves, but it's got a solid shape. And the Dawn dishwashing liquid it's a solid. Just, well, it's a liquid, but you can move it. Examples of solids are chairs, like this that I'm sitting on, books, tables, because it's solid, it's not going nowhere, trees. Liquids have a definite volume. This is liquid, not solid. It's liquid because it moves, and the milk moves, and the food coloring, it moves. So, examples of liquids are water and orange juice, but of course I showed you some. Gases have no definite shape and no definite volume. So, when you burp or anything else, it's a gas. That's what it is. Examples of gases are oxygen that we breathe in, like the oxygen from the trees, it's gas, and helium that fills a balloon, and we all know that because you see balloons floating all the time. Along with differences in shape and volume, the different states of matter have other unique properties. For example, surface tension is a property of liquids that describes the attraction of liquid particles that are at the surface. So, this is really cool, I found this out. The strong attraction of the particles of the surface of the liquids, it creates a surface film. I thought that was really strange. It creates a surface film that makes moving an object through the surface of a liquid more difficult than moving the object when it is completely submerged in the liquid. So, you know how it feels like everything's pushing against you whenever you swim, or you feel light as air sometimes if you swim? That's why. Surface tension is also the reason why liquids tend to keep a low surface area. For example, water droplets will tend to form into a sphere other than spreading out flat. So whenever it falls from the sky, you know how it always looks like a teardrop, or whenever you cry, it always slides down your face. It's not going to go flat till it drops off the face and onto a surface. Milk is a white liquid that we all know because I like milk. It's a white liquid produced by female animals such as cows. Good job, you guessed it. And it's primarily the source of nutrition for young mammals until they can digest other foods, like humans, or any other animal, like birds, well, birds eat little food, but like puppies, kittens. Humans, especially other children, often consume the milk of other mammals, so we drink cow's milk as part of their diet. In the United States, cow's milk is produced on an industrial level scale and is the most commonly consumed form of milk. Milk is mostly made of water, but it also contains vitamins, minerals, and fats, and proteins. So, water has a very high surface tension because of strong attraction between the water molecules, hydrogen bonding, and because the milk is primarily water, also it has a high surface tension. In this experiment, the high surface tension of the milk supports the food color dye, and it will relatively centralize it. So this means the tendency to keep it low surface area minimalizes it and the distance, and the dye will spread and go across the milk surface. So we're going to watch that happen in a minute. That's why it's called milk rainbow. In contrast, the soap is can you guess what it is? Good job. It's a surfactant. It's a surface active agent. It is a substance that has the ability to reduce the surface tension of the liquid. Therefore, when a drop of liquid dish soap is added to the milk, the surface tension of the milk is reduced even lower. So as this occurs, the fat of the milk and the protein particles, the milk can move more freely, which means it'll go really fast and easily. In addition, the soap interacts with the fat and protein particles in the milk, letting them move around faster. This action can be seen as the dye swirls through the milk, so it's going to make a big rainbow and swirl. So, we're going to see how this is. Wasn't expecting that. So, you're going to take a little bit of the milk. If it's whole milk, you can use whatever milk. I got this from the store. As you can see, I've drank half of it. So, we're going to put a little bit in my cup. Probably need a little bit more of that. Okay, so I'm going to fill the little glass platter up. As you can see, I probably need a little bit more just so it's covered. Okay, that's a little bit. Okay, so we got it, right? Okay, so the milk's in there. Next, I'm going to go ahead and do this part because otherwise I'll forget. I'm going to put a little bit of Dawn dishwashing liquid in this little container I have. About a little bit, I just mean enough to cover the bottle. So, and I spilled some. I'm going to go ahead and put my Q-tip in the Dawn dishwashing liquid and let it soak for a minute. Put that over to the side. Find my lid to the milk because otherwise I don't want that to spill. It'd be really bad. Okay, so the next thing, I'm going to slowly move this. You're going to take food coloring. I've got blue. I'll probably do blue and red because you'll see it more effectively that way. So, I'm going to blue, a few little drops of blue. And you can see it from there, right? Like you can see the colors and stuff. Super neat. Okay, so next we're going to add red. I just grabbed a whole bunch of colors because I just wanted to see it would go really, really fast and it would be really neat. There's red. And I'll do green on the inside. Okay. Now we have green. Probably a little bit too much green. Okay, so anyway. Roll my stuff over to the side because it's about to get crazy. Okay, so I have my Dawn dishwashing liquid, and I'm going to put it into the milk. And we're going to watch it as the surface completely goes. So when a drop of liquid dish soap is added to the milk, the surface tension of the milk is reduced. Therefore, the fat in the milk, I'm going to set that down before I drop it. The fat and the protein particles in the milk can move more freely and easily, so you will watch it swirl. In addition, the soap interacts with the fat and protein particles in the milk, causing the particles to move around freely. This action can be seen as the dye swirls through the milk. Are you ready? Here we go. I'm going to make sure that my Q-tip is really good covered with Dawn dishwashing liquid. Here we go. And we'll put it in. Whoa! And we're still, it's bleeding, like it's just like mixing the colors. I'll move it around a little bit. Let's see what cool. And now it's like all mixed. However, I'm curious. So I'm going to try and experiment with myself. I have a hypothesis. I don't know if anything will happen, probably not. But I'm going to put more dishwashing liquid onto my Q-tip and stick it back in and see if it does it again. No, nothing happened. So my hypothesis was correct. Nothing was going to happen. So that was our cool rainbow. Nope, rainbow today. It has all the projects or little things that you should have at home, like Dawn dishwashing liquid, a platter, milk, food coloring, Q-tips. Anything that you have at home to do that. Super neat to watch it go. And the reason behind it. So, if you will wave at me again, we're going to do our mad laugh. And I will see you all next Monday for a fairy tale related summer reading science experiment because I'm going to look some up. So, we're going to laugh. Are you ready? You go with your craziest science laugh in 3, 2, 1. I'll see you guys next Monday.